Hey guys, today we are going to see how to merge two binary search trees to form a sorted linked list. So what does it mean? See, if these are the two binary search trees and if we want to merge these two binary search trees and form a sorted linked list, then what it will be? See here. So at first, let's write all the values in this binary search tree 1 as in the sorted order. Okay, so see 1 2 8 10. So as you know, if you take in order traversal of a binary search tree, then you get a sorted order of the values in that binary search tree, right? So this is the sorted order of values in this binary search tree. Then for binary search tree 2, let's write the sorted order. See 0 3 4 5 and 6. So this is the sorted order of values, right? Now we want to merge these two binary search trees to form a complete sorted order, means a complete sorted linked list. So what will be the result? See, so if we merge these two linked lists, suppose this is one linked list, this is second linked list, and we want to merge these two linked lists. So see here, here it is 1, here it is 0, so 0 is smaller. Okay, so 0, then 1 2 3 4 5 6 8 and 10. I have directly written it here. I am going to explain how to merge these two linked lists, then how to traverse these two binary search trees with in order traversal and form these respective linked lists. So let's go for that explanation now. So I hope you have understood the problem statement now, which is merge these two binary search trees to form a sorted linked list, right? Now let's go for the steps to do it, right? Now the first step is perform in order traversal on both binary search trees, correct? See, in order of root 1, in order of root 2 means what? See, for binary search tree T1, this is the root 1, then this is the root 2. So perform in order traversal on these two binary search trees and form the respective linked lists, right? You want to find out the respective linked lists here. And after forming these linked lists, you have to merge these two linked lists. Okay, so the step is like this. In order of root 1 will give you A1, this is the head of first linked list. In order of root 2, that is A2, this is the head of second linked list which is formed, and then merge those two linked lists. If you remember, I have a video on my channel about how to merge two linked lists. Okay, here in this video as well I will explain that, right? Now let's go for the steps in detail now. So first, in order of root 1. Now here I have written the in order function. Now when we pass root 1 to the in order traversal, so that is the root 1. So let's pass the root 1 to the in order function. So what it says, as you are aware of in order traversal, you know how it works, right? So what is in order? In order traversal is first left child, then root, and then right child, correct? So left, root and right, that is the in order traversal. So see, while root means if it is not null, let's go for the recursive function in order root points left. So you have to first traverse the left part of that tree, correct? So you go to left part. So this is the root 1. So you come to the left node, right? In order root points left. So you come to the left node here. So now the control is on the left node, that is node 2. Okay. Now again, as this is the recursive function, now 2 is passed. This is going to be executed again for node 2. Correct. So again, while root, in order root points left. So again you will go to left. Again this is the recursive function. So now again this will be executed for node 1. So while root, in order root points left. Now you go to left. Now left is null. Correct. So it is executed for null now. So this while condition, while null, so this condition fails. So you come out of the loop and you come out of that function now. Means you come out of that recursive stage. So you went inside that function from here. So now you come out of that, right? So those people who are not understanding this, I have a separate video on Inorder traversal. So in that video I have explained it in detail. In this video as well you will get it, but in case if you want some extra information, you can watch that video. So now, so you come out of this recursive stage. Now create linked list. So when you come out of this, what it means, you go back to the previous node. Correct. Now for 1, see, create linked list, root points, data. So you go to create a linked list with this node. So this data is passed. So data 1 value is 1, right here. So 1 is passed to create linked list function. Correct. Now what is create linked list function? So I have written that function here. To summarize this function, it is the function which creates a linked list of the nodes which is passed to it. Okay. So see, now see here, data is, value is passed. Value of that node means the data of that node is passed to create linked list. So see, what is data? So the structure of the node for this binary search tree is like this. See, struct node, then node star left, then int data, and node star right. Okay, got it? So it is the data, right? So left, data, and right. I have written it intentionally for the Inorder traversal here, that left, data, and right. Okay. Now that data is passed to the create linked list function. So now here, see, sorry, it should not be p here, it should be value. Correct, because the value is passed here, right? So the value comes here. Now with that value you have to form a node. Okay, you have to form a node which is the node of that linked list. So see, p is equal to node star malloc size of node. So you form a node, then p points data is equal to value. The value is 1. Correct. Now p points next equal to null. Now current points next equal to p. Now what is current? See, so this current node is a global variable of type node star, means the node which is there for singly linked list. So what is the structure of a node for this singly linked list? So that structure will be, see, this node. What is the structure? You know the structure of a singly linked list. Struct node, then node star next, and int you can say data. So that is the structure of this node. For a singly linked list, you know the structure. So that is the structure, and of this data type, this is the current variable. So this current pointer, this variable is a pointer. So this pointer always points to the current node of the linked list. Current node of that linked list. So as this linked list will go on increasing, this node will go ahead, which is whatever is the current node of that linked list. So when it is the first node, see here, when it is the first node of that linked list, this current will be null because it is not yet assigned any value. So see, this linked list is not there, so this declaration for this current will be null. So when it is the first node of that linked list, which is P, okay, the value is 1, okay, when it is the first node of that linked list, current will be null. So in that case, see, here there will be one if condition, that is if not of current, means if it is the first node, then current equal to P, means current will point to P, else you can go for this. Okay, got it now? So this is a general code. So whatever the code I have written it here, it is pseudo code, correct? This is also pseudo code. Now the corner cases for that code, don't worry about that, they will be handled in code. I am going to make a video about how to code this, so I will explain the corner cases as well. Just for your understanding, I told you this, but those people who know linked list well will understand this very easily. Okay, so now see, so this is the first node, we have formed it. Now current will point to this node. Okay, now just forget about the code part, let's go for in order traversal of this binary search tree. See, now after 1, left is over, so let's go back, next node is 2, so join that node in this, correct? We are forming a linked list by doing an in order traversal. So I joined this node 2 here. Okay, now current points to this node. Okay, and P points to this node, right? We form a node, then assign value to that node, then the next pointer of that node is null. Okay, you know these conditions, P points data equal to value, P points next equal to null, and then current points to that node, that is the current node. Okay, so now again see, from this 2, now check whether there is any right side, because left side is over for this 2. Check right side is not there, that is null. So go back and now go to the parent, right? So now 8, so attach 8, P points here, that is null. See, this is node P which is formed, and now current points to the current node. Now again go to right. Okay, the right side there is node 10, so form that node, P is the name of that node, P points next equal to null, and current points to that node, right? So again go to left of 10, that is null, go to right, that is null. So come back, again come back, and then you come out of this binary search tree. That means the binary search tree is over. This is very easy, this is just an in order traversal to form a singly linked list out of that binary search tree. Now in the same way, let's form the singly linked list for this binary search tree. So let's do it now. So see, what is the first node, that is 5, go to left, again 3, then go to left 0, go to left, that is null. So come back, left is over, left side is over, come back, this is the parent now. So what is that node, that is 0, as this is the first node. Okay, see, node P is formed, value is 0, the next pointer of that node is null, correct? Now so if not of current, see, as this is the first node, current will be null at first, so in this case current directly points to P. Okay, this node is P, As you know, this node is P and current directly points to P. Okay, and from next nodes, current points next equal to P, means with reference to that current we will go on extending that linked list. That is the basic principle of the singly linked list. Okay, now 0 is over, go to the right, there is null, so come back again, go to 0's parent, that is 3, attach 3. Now that is P is pointing to 3, that is null, that is the node name is P here, and see current points to 3 now, correct. Then for left part of 3 is over, then its value is over, then go to right part, so that is 4, node P is 4 now, next is null and current points to that current node now. Okay, now 4 is also over, go to left, go to right of it, both are null, so come back, this is done, this node is done, so go back, this node 3, this is also done, so go back, right. Then for 5, so that is the node which is not yet means which is not yet included in the singly linked list, so let's include it. 5, node name is P, next is null and current node is now 5. Okay, now left part of 5 is over, its tracing is over, then go to right part of 5, now that is 6. So 6 is P, then current, and next is null. Okay, formation of that node. Now after 6 is done, its left is null, right is null, go back, 5 is also over, so come out of that tree. Now in the starting of this function, I forgot to tell you one thing. You always have to keep the trace of the head node for this two linked lists. Okay, so they also will be the global variables. I will say them as node star A equal to null. I am declaring them as global variable, node star B equal to null, and this A will point to the first node of the linked list. So inside this if condition, when it is the first node of the linked list, see, I will write else here, one more line here inside this if condition, that is A is equal to P. So A will always keep pointing to the head node of that linked list. Okay, and in else part then we will go here. So sorry about that, I forgot to tell you, you have to always trace the head node of that linked list. So those people who know singly linked list, they know they have to keep trace of the head node of that linked list. So B keeps the trace of the second binary search tree linked list. Okay, see, so now we got two linked lists. Okay, and we have to merge these two linked lists to form a sorted complete linked list. Okay, now you can see individually these two linked lists are sorted individually, means this linked list is sorted and this linked list is sorted. Now we are going to merge these two sorted linked lists, okay, to form a final linked list, which is the sorted order of these two binary search trees, right. So these are the two linked lists here, and we are going to merge these two linked lists. Okay, these are the heads of these linked lists. Remember, we are going to have a coding video on this topic, so don't worry about these coding details, just understand the concept. So the concept is that first form a singly linked list by using Inorder traversal for both binary search trees, and then merge these two singly linked lists. Okay, now let's see. So how to merge these two linked lists? See, node A is pointing to 1, node B is pointing to 0. So compare the values of node A and B. See, so if A points value is less than B points value. Okay, if it is lesser, which is not in this case, 1 is not less than 0. Okay, so we will go in else in this case, correct, because A's value is not lesser than B's value, right? But if A's value would be lesser than B's value, what will happen? See, A will be passed to create linked list function, means that's a new linked list which is being formed. So I will write it here. See, new linked list. Okay, so here I will form that new linked list, correct. Now, so A is passed to that linked list. Else it is simple, B is passed to that linked list, means whichever is lesser, that is passed to the new linked list function, means that is passed to form the new linked list. Okay, so in this case B is passed, correct, because B is lesser. Okay, so see, so 0 is passed here. Now the first node is 0 for this linked list. Again, for this linked list as well, store the head. Okay, so I make it pointed by head node. So that is always the starting node which we have stored now to trace this linked list. Okay, now, so until here you understand. Now again go in this function. If A's value is lesser than B's value, you create that linked list, you pass that node, or you pass node B if it is lesser. After passing both, in these both cases, you have to increment that. Okay, so for A it will be A is equal to A points next. For B it will be B is equal to B points next. Until what it will continue? Till one of the pointers, that is A or B, goes to null. Till that this function will go, correct. So now what was the first step? Create linked list B, because B is smaller. So this if condition failed, we went into the else and we passed B to this new linked list function. So we do B is equal to B points next. So B goes to next node. Now again, okay, again come here. So this is in while loop now. This is in loop. A points val is less than B points val. See, 1 is less than 3. Yes, correct. So pass A, that is 1 here. That is the next node, correct. And A is equal to A points next. So whatever is passed, it is going to the next node. This is so simple, right? You know this merge function. On our channel there is a video for this function. Okay, now again see, I will not look at the function now, I will directly do it with this algorithm. Okay, so 2 is less than 3. Yes, so pass 2 to this linked list and A goes to next. Then 8 is less than 3. No, so pass B to this new linked list and B goes to next. Again 8 is less than 5. No, so pass 5. See, whatever is lesser, we are passing it to the new linked list, means we are forming it a new linked list by that node. Okay, so 5 is passed and B points to next. 8 is less than 6. No, so 6 is passed here and B points to next. Now B goes to null. So anyone goes to null, it means that linked list is over. So whatever is remaining in the other linked list, just pass it. So pass A, that is 8, and A will go to next, and now pass 10 here and A will go to next. Now A is also null, B is also null, so this new linked list is over. So this is the merged new linked list, that is 0, 1, 2, 3, 5, 6, 8, 10 and null. So this is how we have merged these two binary search trees to form a sorted linked list. We are going to have a coding video on this in this week only. So please stay tuned and subscribe to this channel to get the coding video for this topic.